take a look at constructing a confidence interval for a population proportion. Now those of you that have had me in class, obviously, you know that I'm a pretty shameless video game nerd, and I've been playing this one quite a bit lately, Elder Scrolls V Skyrim. It's a pretty huge game. There's so much you can do, so much to explore, and enemies to fight, things like that. It's pretty complicated too. So I found this website that's been helping me out a little bit, and just to use as a reference, and I don't think of it as cheating or anything, but it's basically a Wikipedia for all of the different Elder Scrolls games. And when I was on there, I noticed this link that said random page, and that got me thinking, well, I wonder what proportion of all the pages on this website are about Skyrim, because they're about all 5 games, and plus the online apparently. And I wanted to know what proportion of all their websites are about this game. Now that is exactly the type of thing that a confidence interval will help you estimate. So in the data collection phase here, I'm clicking on the random pages over and over, kind of keeping track of whether it's a page about Skyrim or whether it's a page about something else. It doesn't really matter what else it's about, I'm just kind of tallying up as I go how many I'm counting up that are about Skyrim. So I'm going to take a sample of about 100 here, and I'm going to count up how many were about that game. And I'm going to take however many were about that game, divide it by my sample size, and that will be my estimate, my sample proportion. So now that it's all said and done, I've taken my sample of 100, and 16 of the pages were about Skyrim. So my sample proportion, my point estimate, is 16 over 100, which is 0.16. So what I want to do is calculate a confidence interval around that estimate. So one of the things about confidence intervals, why we use them, are that it's very rare to actually pinpoint the population parameter exactly. It's really hard to get it just spot on with pinpoint accuracy. So what we do is we build an interval around that estimate so that we can get a range, sort of an interval of plausible values for that true proportion to fall into. Now, anytime you are calculating or constructing a confidence interval, this is an inference procedure, and our book refers to this process as the Inference Toolbox. So anytime you are constructing a confidence interval, you need to follow these 4 steps every time. So step 1 is to state the parameter of interest in context. Step 2 is to state which procedure you will run and show that all necessary conditions are met to run that procedure. Step 3 is to perform the calculations, and step 4 is to report your findings in context. So just to recap what our condition checks will be on this one, since we're looking at a confidence interval estimating, our estimate is p hat, the conditions that we need are to show that n is greater than or equal to 10n, so we can use the sigma formula. And we also need to show that np and n1 minus p are both greater than or equal to 10, so that we can use the normal approximation. So let's go ahead and get into actually calculating and constructing this confidence interval. So the first thing that we need to do is just really state the parameter of interest. So what are we going to estimate? What are we going to do? We're also going to add in there that we're running this at the 95% confidence level. So there's step 2, is explaining what procedure it is we're going to run, and now we need to show that the conditions are met to do that. So the first condition is that n has to be greater than or equal to 10n. Well, the population is given on the main page. It says that there's over 41,000 articles on this website. So we took a sample of 100, so 10 times that is 1,000. So the population of more than 40,000 is definitely bigger than 1,000. So that condition is met. And we need to show that NP and N1 minus P are both at least 10. Well, our sample size was 100, and we don't know what P is. We don't know the true parameter. So the best thing we can do is use P hat, which was 0.16, and show that that is greater than or equal to 10. Well, that's going to be 16, which is greater than or equal to 10. And when we do this for n times 1 minus P, we have 100 times 0.84, and that is going to be 84, and that's also greater than or equal to 10. So all the conditions here are met to be able to run this procedure to construct this confidence interval. If these conditions aren't met, then any results we get are basically garbage. They're worthless. But they are met, so we know that we have some valid results from what we're going to do. Next thing to do is construct our confidence interval, calculate it. So the general form for a confidence interval is it's the estimate, p hat, plus or minus the critical value, how many standard deviations are we going from that estimate, z star, times the standard deviation of that statistic. So p times 1 minus p over n. So we know our confidence interval is going to be centered around p hat, which is 0.16. So we need to know what that critical value is. So if we are using the normal curve here, which we are, and we're doing this at the 95% confidence level, we need to figure out what is that value of z star such that 95% are in this middle region. Well, you can find that on the Inspire by using inverse norm, but be really careful, because when you use inverse norm, it's looking for the entire area to the left. It's actually going to include this tail, which is 0.025, because that's also 0.025, because it adds up to 1. So if you use inverse norm with the area of 0.975, leave the mean as 0, standard deviation is 1, it'll give you your z star, which is 1.96. So we have 1.96 times our p. We don't know p, so we'll have to use p hat in its place. 0.16 times 1 minus 0.16 over our sample size of 100, and our confidence interval is 0.16 plus or minus 0.072. That's our margin of error. So that takes care of step 3. We have calculated and constructed this confidence interval, and the last thing to do is interpret what that means. So that's the last step, is our interpretation. We are 95% confident that the true proportion of Skyrim pages is between 0.088 and 0.232. Make sure that when you are doing your interpretation that you're using context. It's always easy to forget about the context, but make sure you're putting in there what it is that we are actually doing in context. So that right there, that is a full process of constructing a confidence interval. We started out with some data collection and found our estimate, 0.16, out of a sample size of 100. Had to explain what it is we were going to do. We were going to estimate the proportion of pages about Skyrim. Then we had to just state what procedure we were going to do. We were going to construct a 1 proportion z interval at the 95% level, and then we showed that all the conditions for doing that were met. Then came step 3, where we made our calculations. So using our sort of structure for what a confidence interval is, we found what z star is, plugged in all our numbers here, and our confidence interval was 0.16 plus or minus 0.072. Then finally we had an interpretation of what that meant, that we're 95% confident that the true proportion of Skyrim pages is between 0.088 and 0.232.